charge controller. Charge controllers are used to protect the battery from getting overcharged or over-discharged, and also stops the reverse flow of charge from the battery to the panel. There are mainly two types of charge controllers. They are PWM charge controllers and MPPT charge controllers. MPPT charge controllers are the best for larger power systems, but for small systems like this, PWM charge controllers are enough. This is a 40Ah lead-acid tubular battery manufactured by JC Batteries. What's the role of batteries in an off-grid solar power system? This is where we store the solar energy collected during the daytime for later use. Even though the capacity of the lead-acid battery is 40Ah, we are not allowed to use 20Ah of a battery because lead-acid batteries has a depth of discharge of 50%. Discharging below 50% of the battery is not good for battery health and life. This is where the plus point of lithium-ion batteries comes in. Lithium-ion batteries has a depth of discharge of more than 90%, but they are very expensive. Most of the house appliances run on AC or alternating current. That's why we use an inverter to convert DC output of a panel or a battery to 230 volt AC. Now I'm going to make a control panel for our off-grid solar power setup. Usually output of a solar panel or the battery is DC or direct current. Voltage may be 12, 24, 48, depends upon the type of systems we use. For larger system size, higher voltage systems are preferred so that we can reduce the current and thus wire thickness. This is the control panel I created for our simple off-grid solar power system. Look at that. And here you can see the charge controller, and on the bottom side of the charge controller you can see the 6 leads right here, 2 for the solar panel, 2 for the batteries, and 2 for the DC output. And the first 2 for the solar panel, and this isolator is for the solar panel, and the solar panel output goes right in here, and it is then passed to this isolator and reaches the charge controller, the positive and negative. And next, the positive and negative for the battery, it goes through this isolator, and these leads has to be connected to the positive and negative terminals of the battery. And the last positive and negatives are for the DC load. And then you can see that another isolator for the inverter. That inverter output goes right in here and is passed to this isolator and reaches this switch box. Here we can easily control the AC load. You must use correct gauge wire to connect system components, especially the wire from control panel to the solar panel. I used a 10 gauge wire or 6 square mm wire since the solar panel is placed not far away. It's recommended to use 8 gauge wire or 10 square mm wire to handle 5 ampere current for longer distances. There are websites where you can easily find out the required wire gauge by entering the current and the distance between control panel and the solar panel. Here I have 250 watt solar panels. The individual panels has a maximum voltage of around 20 volt and a maximum current of 2.5 amperes. Since I am building a 12 volt off-grid system, I have to connect these two panels in parallel so that I'll get an output combined around 20 volt and 5 amperes. Now we have to connect these wires to the positive and negative terminals of the battery. And also we have to connect the inverter input leads directly to the battery. I do not recommend connecting the inverter input leads to the charge controller's DC output because if you draw more power from the battery than charge controllers are rated for, it will fail the charge controller. So instead of connecting inverter input directly to the charge controller, connected directly to the battery. But the problem is when you connect the inverter directly to the battery, the charge controller's over discharge protection facility won't be available. The solar panel output goes right in here. Connect it. Now I'm gonna test this solar panel output. Just to turn on the isolator for the solar panel. And you can see that the solar panel is generating 21.5 volt and battery is absent. Battery is absent. It says the charge controller says battery is absent. Of course, battery is absent. Okay, then always turn on the battery first in off-grid solar power system. And then you can see that 12.7 volt. The battery is a new one, so it already has 12.7 volt. And then turn on the solar panel isolator. And you can see that the solar panel is here. Solar panel is connected to the battery and it is charging the battery. And the voltage is 12.9 volt. Yeah, our solar panel is now charging the battery perfectly. And the output goes right in here, the DC output and DC load. Wow, the DC load is working. Okay, so this is a DC based off-grid system is ready. And now we have this inverter for an AC based off-grid system. Turn on the inverter and the now inverter has started to convert DC output of a battery to AC, and then turn on the AC isolator and it then reaches the switch box. Right here you can see the AC loads. Turn on the switch. Yes, our AC load is also working. So our off-grid solar power system, both DC based and AC based off-grid solar power system is now working perfectly.